Over the last few decades, NASA has been at the forefront of Mars exploration with one goal in mind: to search for signs of life on the red planet and help us better understand all the factors that go into determining if habitability is possible in the universe or if we humans are truly alone. The Curiosity Rover has arguably done more for the advancement of these studies than any other mission before it. Let's take a look at this ingenious explorer and all the evidence of life it has found on Mars to date. The Curiosity Rover was the most ambitious Mars mission of its time flown by NASA. The rover landed on Mars in 2012 with the primary mission to find out if Mars is or was suitable for life. Another objective is to learn more about the red planet's environment. In March 2018, it celebrated 2,000 sols on the planet, making its way from Gale Crater to Aeolus Mons, also referred to as Mount Sharp, where it has looked at geological information embedded in the mountain's layers. Along the way, it has also found extensive evidence of past water and geological change. One thing that makes Curiosity stand out is its sheer size. Curiosity is about the size of a small SUV. It is 9 feet 10 inches long by 9 feet 1 inch wide and about 7 feet high. It weighs 2,000 pounds. Curiosity's wheels have a 20-inch diameter that helps it traverse the rough Martian terrain. Engineers at NASA's Jet Propulsion Laboratory designed the rover to roll over obstacles up to 25 inches high and to travel about 660 feet per day. The rover's power comes from a multi-mission radioisotope thermoelectric generator, which produces electricity from the heat of plutonium-238's radioactive decay. The spacecraft launched from Cape Canaveral, Florida on November 26, 2011 and arrived on Mars on August 6, 2012 after a daring landing sequence that NASA dubbed 7 Minutes of Terror. Because of Curiosity's weight, NASA determined that the past method of using a rolling method with land bags would probably not work. Instead, the rover went through an extremely complicated sequence of maneuvers to land. From a fiery entry into the atmosphere, a supersonic parachute needed to deploy to slow the spacecraft. NASA officials said the parachute would need to withstand 65,000 pounds to break the spacecraft's fall to the surface. Despite these mammoth challenges, the rover successfully touched down on Mars, starting a new era of interplanetary exploration. The rover has a few tools to search for habitability. Among them is an experiment that bombards the surface with neutrons, which would slow down if they encountered hydrogen atoms, one of the elements of water. Curiosity's 7-foot arm can pick up samples from the surface and cook them inside the rover, sniffing the gases that come out of there and analyzing them for clues as to how the rocks and soil formed. The sample analysis of Mars instrument, if it does pick up evidence of organic material, can double-check that. On Curiosity's front, under foil covers, are several ceramic blocks infused with artificial organic compounds. Curiosity can drill into each of these blocks and place a sample into its oven to measure its composition. Researchers will then see if organics appear that were not supposed to be in the block. If so, scientists will likely determine these are organisms hitchhiking from Earth. High-resolution cameras surrounding the rover take pictures as it moves, providing visual information that can be compared to environments on Earth. It didn't take long for Curiosity to find what it went to Mars to look for. Chemical analyses show that a grayish powder taken from the rover's first drilled rock sample contains clay minerals formed in water that was slightly salty and neither too acidic or too alkaline for life. Previous missions to Mars have spotted clay minerals, and Curiosity itself had already found signs that liquid water once flowed across the surface. But the pinch of powder tested by Curiosity from a rock nicknamed John Klein is the first hard evidence of waterborne clays in a benign pH environment. To date, it was the only definitive habitable environment that was described and recorded on the Martian surface. X-ray analysis showed that the ground-up rock comprised mostly igneous minerals such as feldspar, pyroxene, olivine, and magnetite. But at least 20% of the rock was made up of clay minerals, such as smectite, that form in the presence of water. The salts in the rock, such as halite, are of the sort that life tolerates, unlike the iron salts found elsewhere on Mars by other rovers, which indicate an acidic environment. Besides hunting for habitability, Curiosity has other instruments on board that are designed to learn more about the environment surrounding it. Among those goals is to have a continuous record of weather and radiation observations to determine how suitable the site would be for an eventual human mission. In December 2013, NASA determined the radiation levels measured by Curiosity were manageable for a crewed Mars mission in the future. A mission with 180 days flying to Mars, 500 days on the surface, and 180 days heading back to Earth would create a dose of 1.01 sieverts. This is within the acceptable range for a human body to endure. Curiosity landed inside Mars's 96-mile-wide Gale crater on a mission to determine if the area could ever have supported microbial life. The rover team soon determined that Gale's floor was a potentially habitable environment billions of years ago, harboring a lake and stream system that likely persisted for millions of years at a time. In a recent study, the research team looked at 24 powdered rock samples that Curiosity collected with its percussive drill from a variety of locations between August 2012 and July 2021. The rover fed this material into the SAM instrument to identify and characterize carbon-containing molecules that are the building blocks of life on Earth. The scientists found that nearly half of these samples were enriched in carbon-12, the lighter of the two stable carbon isotopes compared to previous measurements of Mars meteorites and the Martian atmosphere. These high carbon-12 samples came from 5 different locations within Gale crater, all of which featured ancient surfaces that had been preserved well over the eons. On Earth, organisms preferentially use carbon-12 for their metabolic processes, so enrichment in this isotope in ancient rock samples here is generally interpreted as a signal of biotic chemistry. But carbon cycles on Mars aren't understood nearly well enough to make similar assumptions for findings made on the red planet. The researchers came up with 3 possible explanations for the intriguing carbon signal. The first involves Mars microbes producing methane, which was then converted into more complex organic molecules after interacting with ultraviolet light in the red planet's air. These larger organics then fell back to the ground and were incorporated into the rocks that Curiosity sampled. However, researchers state that similar reactions involving UV light and non-biological carbon dioxide, by far the most abundant gas in Mars's atmosphere, could have generated the results as well. It's also possible that the solar system drifted through a giant molecular cloud rich in carbon-12 long ago. For now, all 3 explanations fit the data at hand. However, researchers agree that more data is needed to rule these explanations in or out. The new find is especially intriguing because of the carbon-12 enrichment, but Curiosity has detected organic compounds on Mars before. For example, the mission team previously reported the detection of organics in powdered rock samples. The 6-wheeled robot has also driven through plumes of methane, the simplest organic molecule, on multiple occasions. It's unclear what's producing Mars's gaseous methane or how old it is. For example, the compound may be generated by microbes busily metabolizing beneath the frigid Martian surface today. It could alternatively be produced by underground interactions of rock and hot water with no life involved. It could also be ancient material, produced either by organisms or abiotically, that was trapped underground long ago and occasionally burps up into the surface today. The Curiosity team would love to drive through another methane plume and determine its carbon-12 content, exploring the origins of these organics further. But that would take a lot of luck, given that researchers cannot predict when and where such plumes will appear. Further data from NASA's newest rover, Perseverance, could also come in handy. The rover landed in a different crater on the planet in February of 2021 and has been hard at work since. Perseverance is hunting for signs of ancient Mars life and collecting dozens of samples that will be returned to Earth for analysis, possibly as early as 2031. If you like the video, please consider checking out this video, which talks about NASA's newest rover, Perseverance, and how it found signs of water on the Martian surface. Do you think we should build a colony on Mars? Please share your thoughts in the comment section below.